So now we will study the PT diagram. Okay, so we have seen the PV diagram in detail. Now we will plot the PT diagram. Again, see, we will consider the solid form. Here it is, you have a solid here. So if it is water, then it will be ice. Let it be at minus 25 degrees Celsius. And then, so if it is heated, it will become solid. So now it is in a saturated state, that is 0 degrees Celsius. If it is water, it will be at 0 degrees Celsius. And then it will become, okay, it will become liquid. So there is a phase change process. Again, it will become saturated. So it is 1, 2 and 3. So it will be there is no change in temperature, 0 degrees Celsius itself. Now it is heated. So now it will become saturated liquid. Okay, it is 4, it is saturated liquid. So this will be, if it is water, it is 100 degrees Celsius at 1 atmospheric pressure. Now if it is heated, all of these will be converted to vapor. Okay, that is at 100 degree Celsius, that is saturated vapor. So it is 0.5. Then if it is further heated, you will get superheated vapor. Okay, that is vapor, that is superheated. Okay, so maybe it will be at, if it is water, at 120 degrees Celsius at 1 bar, it will look like this. So so this particularly I have drawn this for water, but this can be applied to all the substances. Okay, so for different substances at different pressures, these temperatures will be different. Okay, now let us plot these points in a PT diagram. Okay, so I am drawing a PT diagram here, that is pressure here, y-axis, and temperature in the x-axis. So that means for a constant pressure line, right? Okay, so let us draw it here. It's a constant pressure line. So this will be 1. Okay, so that is the solid state. Now the saturation state, see, let this point be 2. Okay, so how will you plot? So from 1 to 2, you know that temperature increased. So you can see that at constant pressure in the x-axis you have temperature, so the temperature is increasing. But this process 2 to 3, you can see that temperature is not changing. Okay, that is, that solid melts to, that is a phase change process. Solid is melting to liquid, that is a fusion process. Okay, so that means 3 will coincide with this point, right? So after that, 3 to 4, temperature is increasing from 0 to 100. For any other substance it will be different. For water it will be 0 to 100. Okay, so that means you can plot 4 here. Then 4 to 5, again that is a constant pressure, constant temperature process. In the phase change process, temperature is not changing. So that means 4 and 5 will coincide. And after that, if you heat, so temperature increases, so it will become, so you will have 6. Okay, so you can do this for different pressures. And so if you draw a different pressure line, okay, it will be different. So that means, okay, so it is 2 dash 3 dash 2 dash 3 double dash. Okay, it is 4 dash 5 dash. Here it is 4 double dash 5 double dash. Okay, so if you connect it, so you will get a curve like this. So if you connect it, you will get a curve like this. So this is not for water. See, water, there is a small change. So, and why we are getting a curve like this? Let us take this 4, 4, 5 and 4 dash 5 dash. See this 4, this phase change process. So 4 to 5 is a phase change process that is happening at a particular pressure and temperature. So if you increase the pressure, so that means here this will be at a higher pressure. This 4 dash P4 dash is greater than P4. Okay, so when the pressure is increased, you know that the saturation temperature will also increase. So T4 dash is greater than T4. That is why, so it is drawn towards the line, this line is slanting towards the right. Similarly, P4 double dash is greater than P4 dash. And T4 double dash is greater than T4 dash, because see, for 1 atmospheric pressure, the saturation temperature is 100 degrees Celsius. So if we increase to 2 atmospheric pressure, the saturation temperature will be greater than 100 degrees Celsius. We need to find the correct value from the tables, but it is greater than 100 degrees Celsius. Okay. Similarly, for 2, 3, 2 dash 3 and 2 double dash 3 dash, you can see that for when you increase, so that means P2 dash is greater than P2. So that means when the pressure is increased, temperature also get increased, but that increase in temperature is very low. So that is why it is almost like a vertical line. Okay, but it is slanted towards the right. Okay, so this is the fusion curve. Okay, this is the fusion curve, and this is the vaporization curve. Vaporization curve. Okay, now how it will be different for water? So water, the line will be slightly different. That is, see, it will be towards the left. So that is slight leaning towards the left. For other substances, fusion curve will be towards right. For water, it will be towards left. Because the reason for water at higher pressures, that is when pressure is increased, okay, the saturation pressure will be reduced. Okay, this is for water because of the anomalous property of water. Because when the pressure is increased, actually, so we have seen that in the anomalous property of water, how the volume is changing. Just like that, here the temperature is getting reduced. It is different for water. That is why you are drawing it to the left. Okay, so this is all about the PT diagram of water and other substances.